Hi, today we're looking at Functional Skills Maths Level 2. We've got the Training Qualifications UK exam board and we've got Sample Assessment Paper 1. So we're going to start with the non-calculator section. Okay, question 1. Work out 4.002 times 3.5. Okay, so what we can do is we can split this up. And we can think of this as we're going to separately do 4 times 3.5. So we're just going to deal with the whole number to start with. And so if we do that, we've got 4. And I'm ignoring the decimal point here. So we'll do 4 times 5. So 5, 10, 15, 20. 0 carry the 2. And then 3 times 4. So 4, 8, 12. Plus the 2 is 14. And we had one decimal point, or one decimal place, so we'll put decimal point in there for 14. Okay, now what we're left with is this extra bit here. So we've got like the 0.002 times 3.5. Okay, so if we do that and multiply those together, 2 times 5 is 10. 2 times 3 is 6, plus 1 is 7. Now we've got to put the decimal point back in. So we had one decimal place here, and 1, 2, 3 here. So altogether we've got 4 decimal places here. So if we start at the end, we've got to move it 4 to the left to make it smaller. So 1, 2, 3, 4. And then fill in the gaps with zeros. So that means we've got 14 from here. I'll do it. 14.0. And we've got 0.0070. So 0.007. And the 0 at the end we can ignore now. If we fill this in with zeros, so we want to add these two together. So 0 plus 7 is 7. 0 plus 0 is 0. 0 plus 0 is still 0. Decimal point. 4 plus 0 is 4. 1 plus nothing is 1. So we get an answer of 14.007. Now I was trying to think if there's a nicer way to do this. If you can think of a simpler way to do this one, because it's only 1 mark, then do put it in the notes. But for me, I couldn't really think of a nicer way to go about it. Okay, question 2. Work out 12 as a fraction of 60. Give your answer in its simplest form. Well, 12 out of 60 is literally just 12 over 60. Okay, but we want it in its simplest form. So we can look at what numbers go into both 12 and 60. And you might see it and do it in one step. So you might recognise, well, actually 12 goes into 60 because 5 12s are 60. So we could go straight down. We could say, well, 12 divided by 12 is 1. And 60 divided by 12 is 12, 24, 36, 48, 65. So we could go straight down to 1/5, which is the answer. But if not, they're both even numbers. So you could have halved them first. So we could go down to 6 over 30 and then half it again to 3 over 15 and keep going. But eventually you should end up with 1/5. Okay, question 3. Write 3806,265 in words. So first thing I'm going to do is put the commas in because I think this will help me. So count back from the end. 1, 2, 3. 1, 2, 3. So now I can see, well, we've got hundreds of thousands and millions. So we've got 3 million, comma, then 806. Make sure you do it all in words. 806. And the comma, this comma is for thousand. And then we've got 265. go 3,806,000, 265. Question 4. Put these numbers in order, starting with the lowest. Okay, so when we've got a different number of decimal places, it can often help to write them one above the other. So 0.77, 0.701, 0.72, 0.707, and 0.077. Now, to make it easy to compare, any gaps at the end, because they're decimals, we can fill them in with zeros. And now, because they all begin with 0 point, we can actually cover that up and just say, well, let's just look at the ends. So which is the smallest number? Well, all of these are in the 700s at the top. This one is just 77. So that's going to be the smallest, number 1. Next smallest is 701. Then 707. Then 720. And finally 770 at the top. So we said that this one was first. So that's the lowest or smallest. 0.077. Then next one was this one, 0.701. Third was this one here, 0.707. Fourth was this one, 0.7. Well, they just had it as 0.72, so that's okay. You won't lose a mark if you put the 0 on. And fifth was this one here, 0.77. Okay, question 5. Alex pays £435.50 rent each month. Next month, the rent is increasing by 2%. How much will Alex's rent be next month? Okay, so we want to work out what the 2% is, and then we want to add it onto the original. Well, to go to 2%, I'm going to start off by going to 10%, because that's a nice one to work out. 10% of £435.50. Well, we're dividing by 10, so we're just going to move the decimal point once. So it's going to be £43.55. You might think, well, how has that helped us? Well, if we've got 10%, we can now go down to 1%. 435.50. Well, 1%, we're going to move that decimal point twice. So move it once here, we're going to move it again to over here. So we'll end up with we're actually going to be 4.355. And I'm going to keep that, although that doesn't really make sense as money, I'm going to keep it like that for now. Now we actually want 2%. 2% of this. Well, 2% is just going to be 2 lots of this. So we're going to double it, or times it by 2. So 2 times 5 is 10. 2 times 5 is 10 again. Add the 1, that's 11. 2 times 3 is 6, plus 1 is 7. Decimal point. And 2 times 4 is 8. So that gives us £8.71. Okay, and we need to add that onto the original. So we've got £435.50 plus £8.71. Well, 0 plus 1 is 1. 5 plus 7 is 12. Bring the decimal point down. 5 plus 8 is 13. Plus the 1 is 14. 3 plus 1 is 4. Still got 4 there. 4. So we get a total of £444.21. Okay, question 6. Taylor buys a piece of wood to make a photo frame. Taylor uses 2/3 of the wood for one part of the frame and 1/5 of the wood for another part. What fraction of the wood is left over? Okay, so if we add these two together, then whatever's left is going to be the leftover. So in other words, we can then take this fraction away from 1. So what we want to do is we want to add 2/3 plus 1/5. And as you know, because our denominators are different, we can't just add them as they are. We need to change the denominators. 3 doesn't go into 5, so we're going to have to change the denominators of both of these. So we want to find a common denominator, so the lowest common multiple, or in simpler terms, the smallest number that both 3 and 5 go into. A good way to find that is to multiply them together. So 3 times 5 is 15. So that means that 3 must go into it and 5 goes into it. Well, how many times does 3 go into 15? Well, we times it by 5, so we know it goes in 5 times. So we've multiplied that by 5. We need to multiply the top, or the numerator, by 5 as well. 2 5s are 10. Now with this fraction, we multiplied this by 3. So we just need to multiply this numerator by 3 now. So 1 times 3 is 3. So we end up with 10 plus 3, which is 13 over 15. That's how much of the wood has been used up. How much is left over? Well, if we've used 13/15, well, that means we've got 14/15, because 15/15 would be the whole thing. So we've just got 2/15 left over. So what we've done is we've said 15/15 minus 13/15 to get our answer there. Question 7. Remy drives 154 miles. It takes 3 hours and 30 minutes. Remy thinks their average speed was more than 40 miles per hour. Is Remy correct? Okay. So, well, let's think about this. If they were travelling, if the speed was 40 miles per hour, well, how far would they go? Well, let's think of this. 3 hours and 30 minutes. Well, 30 minutes is half of an hour. So we can write this as 3.5, 3.5. So if we now multiply the 40 by the 3.5, 3.5 times 40, that's going to tell us how many miles they would cover if they were travelling at 40 miles an hour. Okay, so we'll change the 35 to the 3.5 to 35 and ignore the 0. Okay, I'm getting rid of the decimal, I'm getting rid of the 0, make it nice and simple. 4 times 5, we've got 5, 10, 15, 20. And 4 times 3, we've got 3, 6, 9, 12, plus the 2 is 14. Right, well, we need to add a 0 to make that 40. But then we've got 1 decimal place here, so we're going to put a decimal point in there. So we end up with 140 miles. Okay, so that's how far they would travel if their speed was 40 miles an hour. Okay, they actually drive 154 miles. So we'll say 154 is more than 140. So that must mean that they were travelling faster than 40 miles an hour. Because 40 miles an hour only gets them 140 miles. If they actually did 154, I don't know how much faster, but we know it's got to be faster. So we can just put, is Remy correct that the speed was more? Yes, they are. Question 8. The table shows the number of stars awarded by some friends to a video game. So 16 people gave between 1 and 3 stars, 5 people gave between 4 and 6 stars, and 9 people gave between 7 and 9 stars. Work out the estimated mean number of stars awarded. So because we've got groups here, we need to make an estimate about how many stars each gave. And the way we do that is by using a midpoint. And what that means is, instead of saying, well, did they give 1 star? Did they give 2 stars? Did they give 3? We're going to assume that they gave the middle number. And we can do that in two ways. We can add the smaller and largest number together, 1 and 3, which gives us 4, and then divide by 2, which gives us 2. Or we can just think, well, if we had the numbers 1, 2, and 3, what number would be in the middle? Well, it's 2. So the same with 4 to 6. Well, the middle number, or the midpoint, would be 5. And the same with 7 to 9. The midpoint would be 8. So if you're not comfortable with that, you can add 7 and 9 together to give 16. Divide by 2, and you still get 8. So now we're going to use the midpoint, so we don't need these ranges anymore. Now, when you're working out the mean, we need to know the total, and in this case, it's going to be the total number of stars, and that's all divided by the frequency, the total frequency. To work out the total number of stars, well, the first thing we need to do is multiply the frequency with the midpoint. Okay, so 16 people gave 2 stars, so that means in total 2 times 16. Well, we can do it here. 2 times 6 is 12. 2 times 1 is 2, plus 1 is 3, so we've got 32. 5 times 5, hopefully you're comfortable with that being 25. And 9 times 8, well, let's do 8 nines. So 9, 18, 27, 36, 45, 54, 63, 72. Right, so the total number of stars is going to be the total of these. So 2 plus 5 is 7, plus 2 is 9. 3, well actually I know 3 and 7 go together nicely, so 3 plus 7 is 10, plus 2 is 12. So for our mean, we're going to need 129, and divided by the total frequency, so that's going to be all of these. 6 plus 5 is 11, plus 9 is 20, and 1 plus 2 is 3. So we've got 129 over 30. Right, so let's try and do this division with the bus stop method. So 129 goes in the bus stop. I'm going to ignore the 0 and just divide by the 3 to start with. We'll put the 0 back in afterwards. So does 3 go into 1? No, because 3 is bigger than 1. What about 3 into 12? Well, we've got 3, 6, 9, 12. So it goes 4 times. And 3 into 9? 3, 6, 9, 3 times. Okay, 3 goes into 129 43 times, but we want to know how many times 30 goes into 129. So all we've got to do is, we're either adding a 0 or we're moving the decimal point. And the way to do it is to think, well, if we're dividing by a bigger number, is my answer going to be bigger or smaller? Well, if it's a bigger thing we're splitting it into, we're going to have fewer of them. So instead of adding a 0, we're going to need to put in the decimal point. So we get an answer, which we can put down here, of 4.3. And that's the end of the non-calculator section. Okay, move this up here. So now we've got the calculator section. Question 1. Draw to scale the side view of this cylinder on this centimetre square grid. The side view. So if you've got a cylinder, well, what are you going to see? Well, you're just going to see, you won't actually see that it's round. All you would see, if you measure like my pen, we can't tell that it's round because this is a cylinder. All we're seeing, if we cut it off here, we'd have a straight line at the bottom. Actually, let me put it down. Straight line at the bottom, straight line at the top. So it really just looks like a rectangle. And how tall is that rectangle? Well, it's going to be 5 centimetres up. And they told us it's 4 centimetres across. So we've just got to draw a rectangle on this grid. which is 5 centimetres by 4 centimetres. And they've also told us it's centimetre square grid. So let's start in that corner. We're just going to count down 1, 2, 3, 4, 5 centimetres that way. We'll go across 1, 2, 3, 4. And now just finish off our rectangle. And that's it. If you want to, you can put 5 centimetres by 4 centimetres, but you don't have to do that. Okay, question 2. Which of these points has the coordinates 2, 3? So we always go across first, so 2 would be here, and then 3 we go up to 3, so it's going to be point B. Question 3. Put these numbers in order, starting with the lowest. Again, I like to put my commas in here. Well, the lowest or the smallest ones are going to be the negative numbers, and we've got 2 of those here. So the smallest one will be the more negative one. Well, minus 100,000 and something is going to be more than minus 82,000 and something. So we'll start with minus 102,498, then minus 82,548. I'll cross them out so we don't confuse us. So now we've got the 3 big numbers. They're all in the millions. 1,200,000, 1,204,000, and 1,024,000. So this one's going to come next. And then 200 versus 204, so this one comes next. And then finally 1,204,812. Okay. Question 4. Calculate 2.5 squared plus 1.5 squared, all divided by 2.5 squared minus 1.5 squared. Remember, we can use our calculator. So actually what I'm going to do is 2.5 squared. Let's work this out separately. Well, 2.5 squared means 2.5 times 2.5. Which gives us 6.25. And we might as well work out 1.5 squared as well, because we're going to need that. So 1.5 times 1.5 is 2.25. So now we can put these values into this. So it doesn't look as complicated anymore, because instead of 2.5 squared, we can put 6.25. And it's still plus. But instead of 1.5 squared, we can now put 2.25. And down here, we can put 6.25 minus 2.25. Now what we can do is do everything on the top. It's almost as if we've got brackets around these. Think of it like that. So we can do our 6.25 plus 2.25 is 8.5 on the top. And at the bottom we've got 6.25 minus 2.25, which is 4 at the bottom. So 8.5 divided by 4, 2.125. Okay, so I wouldn't try and do it all in the calculator in one go. You'll just get into a muddle. And I'm pretty sure with this exam board, they say you can only use a simple calculator. So you wouldn't be able to use a scientific calculator to do this anyway. So it's good to know how you can do it in parts. Okay. Question 5. The world's largest clock face is circular. It has a radius of 21.5 meters. Calculate the circumference of the circle. So it's circular, and the radius, that's the distance from the middle to the outside, is 21.5 meters. Okay, well, the circumference is equal to 2 pi r. Or in other words, 2 times pi, which they've given us as 3.14, times r, which is a radius, which is 21.5. So 2 times 3.14 times 21.5 gives us 135.02. And that was all in meters, so 135.02 meters. Keep the units the same. Question 6. A sports company sells red and blue tennis rackets. Let's put a comma in. 343,980 customers bought tennis rackets last year in total. 51,597 of these customers bought red tennis rackets. What percentage of customers bought blue tennis rackets? Well, first of all, let's work out how many bought blue tennis rackets. So it's going to be what's left. So it's going to be 343,980 minus 51,597. So 343,980 minus 51,597. Oh, no, that was a typo. 343,980 minus 51,597. That's why it's good to go slow. Check what you're doing. That gives us 292,383. We want to turn this into a percentage. So we're saying, well, it's 292,383 out of the original 343,980. And then to turn it into a percentage, we'll multiply it by 100. So we've got our answer from before. Divide it by 343,980. And then multiply that by 100 to give us 85%. Hopefully you can see that on there. Question 7. Keegan wants to buy a new fridge. They see these two offers online. Fridge A, we've got 1/8 off the original price. And fridge B, we've got 18% off the original price. Both fridges have the same original price. Keegan wants to buy the cheaper fridge. Which fridge should Keegan buy? Now, I know some people don't like these questions because they say, well, I don't know how much the fridge is, so how can I work out the discount? Well, what we need to do is compare 1/8 with 18%. Because whichever is the biggest discount, that's going to give us the cheaper fridge. And what we can do is use our calculator. So 1/8 is just 1 divided by 8. That gives the answer as a decimal. If we want to make it a percentage, we multiply by 100. So we get 12.5%. Okay, now we can do a direct comparison where we can say 18 is more than 12.5. So which fridge should Keegan buy? Fridge B. Bigger discount means cheaper fridge. Okay, question 8. An airline asked passengers to complete a questionnaire on their flight. The results are shown below. So we've got quite a lot of information in here. So we're asking whether it's people's first time flying, yes or no. But then we've split it between people that are 40 years old or under 40 years old and those that are 40 years or older. And we're told that one of the passengers who completed the survey will be chosen at random to receive a prize. Monroe writes the probability that the winner of the prize would be 40 or over and a first-time flyer in the newsletter. What is this probability? Give your answer as a percentage. Well, you know I like to have commas in these big numbers that make it easier for me to read them. So I'll put those in first. Okay, starting point. One of the passengers who completed the survey will be chosen at random. So we're talking about all of these people are involved. So the bottom, so although they've asked for the probability as a percentage, I'm going to work it out as a fraction to start with. And we're interested in all 492,787. They could all be picked. But they actually want to just look at the probability the winner of the prize will be 40 or over. Okay, so that's these, 40 years and above, and a first-time flyer. So first-time flyer, so it's only really those. So we want 23,059 out of the total 492,787. That's the answer as a fraction. We could divide them to give the answer as a decimal. To make it a percentage, we need to multiply it by 100. So 23,059 divided by 492,787 times 100, and we get, well, you could do all the digits 4.6793%, or we could round it to, I don't know, 2 decimal places. We'd round it up, so we could say 4.68%. Question 9. A sales assistant has been asked to attend a meeting with their manager. The manager sets a new target to increase the total amount of sales for this year by 12%. The manager asks the sales assistant to estimate whether the new target is more than £165,000. Okay, so we've got the amount of sales for each quarter. So what we want to do first of all is work out what the total amount of sales is for the year, because then we're going to look at whether we're going to increase that, or what we get when we increase it by 12%. Now they said to estimate. So for estimating, what I'm going to do is I'm going to round these numbers, and I'm going to round them. Did they say? No, they don't tell us how to round them, so I'm going to round them to the nearest thousand. So 23,438. So if it's less than 5, we round down, so we can round that to £23,000. 368, so we're going to round that up to £37,000. 485, so 5 we go up, so we'll round this to 49,000. And this one 397, so we go up to 40,000. So if we add these, we'll get a total of 23,000 plus 37,000 plus 49,000 plus 40,000. So £149,000. Okay, now we've got our 12%, so we want 12% of this. So 12 out of 100 times 149,000. Or we can do it in reverse. We can do that times 12 divided by 100 to give us 17,880. Well, if we add that back on, so we've got 149,000 plus 17,880, we get 166,880. Now the manager asks the sales assistant to estimate whether the new target is more than 165,000. Well, we can say 166,880 is more than 165,000. Okay, so we can say yes, it is. Now that's just based on the estimate. The actual answer might not be, because we've had to do some rounding, but they've asked us to estimate, and based on that, that's the answer we get. Okay, question 10. This is a sketch of an empty cylindrical barrel. Can the barrel hold 50 gallons of liquid? Okay, So we've got the measurements. We've got that it's 85.1 centimetres tall. The radius is 28.6 centimetres. We're told 1 litre is 1,000 centimetres cubed. 1 gallon is 4.5 litres. And they've told us to use pi equals 3.14. Now, they're talking about gallons. We've got litres here. So the first thing I'm going to do is get the same units. So I'm going to go from gallons to litres. So if we multiply 50 by 4.5, we can now get our answer in litres. So the question is now actually, can the barrel hold 225 litres of liquid? Right, so to do that, we've got to work out what the volume of this cylinder is to start with. Okay, and the volume of a cylinder is going to be the area of the circle multiplied by the height. So let's work out the area of the circle first of all. So the area is pi r squared, where pi is 3.14. Remember, when you've got a symbol next to a letter or a number by a letter, it means you multiply. So pi r squared, well, r is 28.6, and squared means you multiply it by itself. So for the area, we want 3.14 times 28.6 times another 28.6, which gives us 2,568. I'll keep all my decimal places for now. And that is going to be in centimetres squared because it's area. Okay. Now we want to turn that into volume. So remember, for the volume, we just multiply it by the height. So we're going to multiply it by 85.1. And I've kept my answer in the calculator. And we multiply it to get 218,570.36. And that's now going to be in centimetres cubed because it's volume. Okay, so quite a big number. But remember, that's the volume. When we're talking about liquid, we actually want capacity. So 1 litre is 1,000 centimetres cubed. So we need to divide that by 1,000 to get our answer in litres. So divide that by 1,000. Oh, that was 100. What I'll do is I'll go backwards. I'll multiply it by 100 to get back to where we were. Divide it by 1,000. So we get 218. I'm going to round it to 2 decimal places. So 218.57 litres. Okay, that's the volume. Can the barrel hold? Well, they said, can it hold 50 gallons? Which we said, well, that's the same as 225. Well, we can say, well, 225 is more than 218.57. So, no, it can't. And there's many other ways to answer question 10 as well. So that's just, I've just gone with that because I think that's most straightforward, but you might prefer to do it a different way. You should still come up with the same conclusion. Question 11. The original price of an electric bike Quinn wants to buy is £2,799. There is an 8% discount for a cash payment. Quinn's bank will loan the discounted cash price. The loan and any interest are paid back after 2 years. The bank charges 4% per year compound interest. How much will Quinn pay back to the bank in total? Okay, so he's taking out a loan. We want to know how much he pays back at the end of that loan. But he's not taking out a loan for this amount, because by taking out the loan, he can pay in cash, which means he gets 8% off of this. Now, what you can do is work out 8% of this and subtract it. I'm going to do a bit of a shortcut, which you may or may not like. I'm going to say, well, if we're taking 8% off, so think of, we start with 100%. If we take 8 off, we've got 92. So what we're saying is the actual amount he's going to pay is 92% of this. So we can do 92 divided by 100 times 2799. Yeah, if you don't like this, work out 8% and then take it off, but you will get the same answer. So 92 divided by 100 is 92% as a decimal, times 2799, means that the discounted price is £2,575 and 8 pence. Right, now we've got our compound interest. So the way we do that is we start with the original amount that we're borrowing. It's 4% a year, so 4% interest means that we've got our original 100% plus 4%, okay, which you can think of as 104%. But as a decimal, that is going to be 104 divided by 100, which is 1.04. Now, I know a lot of people will like to just use the formula. I think it's much better to kind of think it through. Yeah, so if we're adding on 4% interest, it's like multiplying by 104%. So at the end of 1 year, this figure will have increased to 2575.08 times 1.04. Now we've got 2 years, so we need to multiply it by 1.04 again. If you just work out 4% and add it on, that's fine for the first year, but for the second year, you then need to work out 4% of the new amount. So it's much simpler and more straightforward to do it this way. So just have to type that back in. So we've got £2,575 and 8 pence. After the first year, that would have increased to £2,678. After the second year, would have increased to £2,785. Because it's money, we just want 2 decimal places, 20. But the next digit is 5 or more, so that's going to make it 21 pence, which we can put in here. Okay. Okay. Question 12. Rope A and rope B were tested to find out which one is the stronger. 12 samples of rope A were chosen. The greatest weight in kilograms that each sample could hold without breaking was recorded. Here are the results. Yes, we've got them all here. Summarised below is the weight in kilograms that 12 different samples of rope B were able to hold before breaking. We've got the mean weight held before breaking, 3,172 kilograms, and the range of weights is 213 kilograms. And I'm going to put this is for rope B. The manufacturer claims, on point A, on average, rope A can hold the greater weight before breaking. And B, the second point, the 12 samples of rope A were more consistent. And their question is the manufacturer correct? So in other words, what we've got to do is work out the mean and the range for rope A and compare them to the mean and range for rope B. So I'm going to start a new column here. So for the mean, we know we want the total divided by the frequency. So let's add these all together. So 3595 plus 2974 plus 3147 plus 3311 plus 3028 plus 3072 plus 3246 plus 3072 plus 3522 plus 3527 plus 3486 plus 3167. Oh, hopefully no mistakes there. It's very easy to make a mistake when you're adding all of those up. 39,147. Frequency, well, we're told there's 12 samples, or we can count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. So we get a mean of, well, 3, 2, 6, 2, 25. Let's do it to the nearest kilogram. So that's going to be, that's less than 5. So we'll have 3,262 kilograms. Right, now we want to work out the range of the weights. Well, the range is the biggest value minus the smallest. What's the biggest? 3,500? Anything bigger than that? No, so that's the biggest one. And what's the smallest value? 2,900. Anything smaller? No, that's the smallest. So the range is going to be 3,595 minus 2,974. Which gives us 621 kilograms. Okay, so we've got all of our numbers. We've got to answer whether the manufacturer is correct, and we've got some boxes to put our answers in here. So the workings, well, we've shown the workings above already. Now, claim A. On average, rope A can hold the greater weight before breaking. Well, the mean weight for A, if we look here, yeah, mean of A is bigger than B. So is the manufacturer correct? We can say yes. And we can put, if we want to write it out, you can put the mean weight for A is 3,262 kilograms compared with 3,172 kilograms for B. And then the second claim was the 12 samples of rope A were more consistent. Well, more consistent would mean that you've got a smaller range. Actually, the range is bigger for A. So for this one, we're going to say no. The range is smaller for rope B, and we can put those in. So that was 213 kilograms versus 621 kilograms. So rope B, or the samples for rope B, was more consistent. Something like that. You wouldn't have to write all of that, but I would repeat the values. So make sure you're giving your answer and you're showing the values that you're comparing. Question 13. Ali is painting a room sea green. Sea green is made from mixing blue paint and yellow paint in the ratio 5:2. The area to be painted is 65.8 metres squared. Both blue and yellow paint are sold in 1 litre tins. A litre of paint covers 12 metres squared. How many tins of each colour paint will Ali need to buy? There's lots going on there. Okay, so what we can do is we can start off by thinking, well, we've got a ratio here, so let's at least draw a ratio table so we can start thinking about this. Okay, because what you're trying to do when you've got all of these words, you're trying to get rid of some of the words and just replace it with numbers or symbols or something easier for you to get a feel for. Okay, so we've got mixing blue paint and yellow paint. So we've got blue, yellow, and we can have a total column. And the ratio is 5:2. And if that's all we had, we would have a total of 7. Okay. Right, so we're the total area to be painted is 65.8 meters squared, so we can put 65.8 here. And what we're trying to do is we're trying to work out how many tins of each colour. So we want to know what these new values would be here. And the way we can do that is saying, well, how are we getting from 7 to 65.8? And we're going to do that by working backwards. We're going to say 65.8 divided by 7. And if we do that, we get 9.4. Okay, so that's saying we're going to multiply the top row by 9.4. So that's going to be times 9.4. That's going to be times 9.4. So 9.4 times 5 gives us 47. And 9.4 times 2 gives us 18.8. Okay. These values are all in litres. Okay, this is how many... oh no, it's not in litres, sorry. These values are all in metres squared, because we're looking at the area. What we want to do is turn it into litres, because we've got each tin holds 1 litre of paint. Okay, so we know we need to cover 47 meters of squared with blue paint, and we need 18.8 meters squared covered in yellow paint. But turning that into tins, well, we've got to divide this by 12, because we know we can get 12 meters squared out of each tin. Okay, so 47 meters squared, divide it by 12. It's going to tell us how many tins we need. So 47 divided by 12, 3.916666. 66, keep going on. But you can't buy that many tins of paint. You can't buy 0.916 of a tin. So we're going to need 4 tins of blue paint. And we can do something similar for yellow paint. We know we want to cover 18.8 meters squared, because we can get 12 meters squared from each tin. We divide it by 12. So 18.8 divided by 12, and we get 1.566666. But again, we can't buy 0.5666 of a tin, so we're going to have to go up to the next whole number. So we need 2 tins of yellow paint. So we can now put those in the answer box. Okay, question 14. Stevie's friend had the rectangular end of their house covered with wooden boarding. The area covered measured 4 metres by 7 metres. The builder charged £1,456. Stevie wants to cover the end of their house, shown below, with the same wooden boarding. Okay, and we've got a diagram here. Stevie estimates how much they can expect to pay. Stevie thinks the builders will charge the same amount per square metre. How much does Stevie estimate they can expect to pay? Right, so a few calculations we've got to do here. What I'm going to start with is by working out how much did they charge per square metre. So the area covered measured 4 metres by 7 metres. So that means the total area must have been 4 times 7, which I'm sure you could do in your heads anyway, is 28 metres squared. Now, if you charge £1,456 in total per metre, we're going to need 1,456 divided by 28, which gives us £52 per metre squared. Right, Now we need to know how many meters squared we've got for Stevie's house. So what we've got here, we've got a shape. We need to split this up really into shapes that we can deal with a bit nicer. You could think of it as one rectangle at the bottom with a triangle on top. I'm going to treat these as two trapeziums. So I've got a trapezium here and trapezium here. In fact, they're going to be two trapeziums the same size. So I'm just going to draw another sketch of it. I've just rotated my trapezium. So that means we've got 8 meters along the top. This bottom length is going to be 11 meters. Up the side, well, it's going to be half of 8.5. So 8.5 divided by 2. So this is going to be 4.25 meters. Now the area of a trapezium can be worked out using a formula: half times A plus B times H, where A and B are the two parallel sides and H is the height. So it's going to be a half times 8 plus 11, and all of that is going to be times 4.25. Well, let's work out this bit in the brackets first. Well, we don't really need a calculator for this, but we'll use it anyway. So half times 19 times 4.25, which gives us, well, I'll put 0.5 for a half, times 4.25, gives us 40.375 meters squared. Now, that is just for one trapezium, but remember we're going to have another trapezium down at the bottom as well, so we want to multiply that by 2, which gives us 80.75 meters squared. Okay, so we've got the total area. We know the price per meter squared, which was £52. So we need 52 times 80.75. We need a pound sign for the answer. 52 times 80.75 gives us £4,199. And I think we're on to the last question. Question 15. Jessie is thinking about covering their garden with artificial grass. And we've got a picture here of their garden. 6 meters, 9 meters, 4.825 meters there. Jessie wants to determine how much it will cost. Jessie uses this information to work out the area of the garden. Now, if you weren't able to answer question 14, or you had a go at it and thought, oh, I'm not sure, hopefully you'd then see this question and think, oh, actually, this is a trapezium. This is what I just did in question 14. So you could actually use this and then go back. You know, if you couldn't remember the formula, you got it here. This is the same as a half times A plus B times the height. It's just, instead of putting a half at the front, they've just said divide by 2. And instead of putting H for the height, they put C. Okay, but it's the same thing. And sometimes you'll find that you might find something in a later question that helps you to go back with something you maybe struggled with or weren't sure about before. Okay, so she's going to use this information to work out the area of the garden. They've given us this formula for the trapezium. And it says, Jessie searches online to find out the cost of the artificial grass per metre. The results are shown in this table. Okay, so we've got loads of different options, lots of different prices. Let's see what we get on the next page. Okay, Jessie uses the modal cost to determine how much it will cost to cover the garden with artificial grass. Jessie thinks it will cost over £800. is Jessie correct? Right, so the modal cost. Well, the mode is the value that occurs most often. So we want to find which number occurs most often. The way I find best to do this is to write them out. So we've got £14.99. How many times do we see that value? Well, we got once. That's it. So it's only once. Okay. What about £24.99? Well, we got it once. Again, that's it. What about £19.99? Well, we've got 1, 2, 3, 4. So 4 times. Then we've got £10.75. Once. Only once. £17. Once. That's it. £15.50. Only the once. £16.95. Only once. And because I've been working down, I don't need to look back up here because I know I've already crossed those off. So then £15.75 is just the once, and £10.95 just the once. So the one we've got the most of is £19.99. So that's what we're going to use as our cost per metre squared. So we need to work out the area of this. Let's bring it down here. Okay, so we know we've got a half. A plus B, well, A is 6. B is 9. H or C is going to be 4.825. Well, there's 6 plus 9. We know that's going to be 15. Okay, so we've got a half. 1 divided by 2 is 0.5 times 15 times 4.825 gives us 36.1875 metres squared. Okay, so now we're going to take that. Let's go on to this sheet now. So, what was that value? We had 36.1875 metres squared was the area. And if you remember, the modal amount that we worked out was £19.99. So we're going to multiply those two together. I've still got this value in my calculator, so I'll keep that there. Multiply it by 19.99. And we get 723. Round to 2 decimal places because it's money, so 38. But this is an 8, so we round up to 39. Okay. Jessie thinks it will cost over £800. Well, no, this is less than £800. So is Jessie correct? No. Jessie is incorrect. And that's the end of the paper. So I hope you found it helpful. Please like the video, subscribe to the channel, turn the notifications on so you get updated when I load new videos, and look forward to seeing you again soon. Thank you.